Hi and welcome everyone to today's presentation, our BI for Hadoop benchmark. The SQL engine wars continue and everybody wins. We appreciate your attendance today. We've got a jam-packed presentation with a lot of really good, interesting information. We actually at one point had thought about naming this BI benchmarks, beards, and bourbon, but our legal department said that might not be kosher. So we're going to stick with the SQL engine wars continue and everybody wins. But definitely going to be some interesting findings shared today. Today's speakers include Josh Klahr. He's our Vice President of Product Management. Josh is really a veteran in this space, working with a number of organizations in business intelligence and big data, including Pivotal and Greenplum. And joining him is Trystan Leftwich. Trystan is our local resident. He's the self-proclaimed doer of all things technical. Trystan worked at Ticketfly before joining AtScale. My name's Irina Lewis. I'll be your moderator today, walking us through the session and getting you to the meat of Josh and Trystan with the details of our benchmark. Before we get started, just really quickly, for us to have an understanding of exactly kind of who we've got in our audience today, I'd like to invite everyone to go ahead and take a vote here. We're going to do a really quick poll about where you are in your big data journey. And so you'll see this pop up. It will be below your screen there, below the presentation screen. And we'd like to get a sense of knowing where you are in that. Are you just starting to think about it? Have you already implemented it? Do you have a large number of nodes? Do you just have a small number of nodes? And so the poll will stay open for about 45 more seconds. And we'll be interested in seeing what everyone has here. I'll be able to share these live. Actually, I think you're seeing them live at the same time. And so you'll also get a sense of what others in the audience. We've got about 300 of you joining us today. And so this gives us a good understanding. It looks like we've got an interesting little split here about those of you thinking about it, and okay, now we've got a little bit more of a variety. Looks like many are early on in their journey, with a number of you doing fairly well with more than 10 nodes. So at this point, we're going to go ahead and wrap up the poll and proceed on. Get to the good stuff here. And so with that, what I'd like to do is I'm going to turn things over to Josh Klahr, and he's going to walk you through and share some of these benchmark findings with you. Josh?
Thank you, Irina, and good morning or good afternoon, everyone, depending on, or evening, depending on where you are in the world. What we thought we would do today is set the stage for the AtScale benchmarks and the way we look at BI-on-Hadoop and how we assess performance. We'll spend a little bit of time talking about the setup for the benchmarks, what our cluster looked like, what queries we ran, what the data set was. Then we'll dive into results. Time permitting, we'll try to do some Q&A at the end. If you folks have questions, please feel free to type them in the questions section of your screen, and we will try to get to those as we go. But let's first dive into the market context. I think everybody out there is investing in data, and specifically for those of you who are thinking about it or just implementing now, you're really looking at big data and big data tools like Hadoop as a platform to improve your insights and ideally your actionable analytics. And maybe you're participating in discussions that look like this, which is essentially, do we have any actual analytics? Have you done Hadoop yet? Maybe you should stick everything in memory. In reality, what we see is there are definitely challenges that enterprises are running into as they're trying to actually get insights and analytics from their big data investment. And what I thought I would share before diving into the actual benchmarks is some context around what's happening in the marketplace. The results I'm going to share with you are from our 2015 version of the Hadoop Maturity Survey. One of the things that we'll include as a follow-up is a link to the 2016 version of the Hadoop Maturity Survey. And if you participate in the survey, you'll be able to get the results of the survey once they're published. But essentially what we found is there's definitely been a shift between 1 or 2 years ago and today in terms of what the major Hadoop use cases are. What we saw in 2014 and before that is a big investment in ETL workloads. Get data on the cluster, potentially remove workloads off of a traditional enterprise data warehouse, and use Hadoop as a batch processing framework. What we see people wanting to do now with their Hadoop investment, and this has been aided in large part by the emergence of the SQL-on-Hadoop engines that we'll talk about later, is starting to think less about ETL and more about analytic workloads, either data science or business intelligence workloads. And so for the 36% of you that are thinking about Hadoop or the 27% that are just implementing it, my guess is that these are workloads that are of interest to you. For those of you who have those big clusters over 10 nodes, you've probably done that ETL work and are now starting to think about what's the next set of workloads that I want to bring to the cluster. But this is kind of a challenge. What we see is that the companies that are able to provide self-service are those that are gaining value from Hadoop. So self-service, access to that data, not just batch data processing, is what's really driving value from those Hadoop clusters. But there are some challenges. Of the folks that we surveyed in our last survey, over 60% or almost 60% hadn't yet provided self-service access to Hadoop. And that created, at least in our minds, a bit of a question, which is if people really are trying to do BI and they're realizing value from self-service access to that data, why aren't they able to deliver it today? And what we see is there are definitely some challenges. If you're trying to do business intelligence and bring tools like Tableau or Excel or other traditional data visualization tools to data sets that are in Hadoop, it's a real challenge. Current BI tools are limited in their ability to deal with Hadoop data from a data structure perspective. Hadoop really is not yet optimized for fast reads of super large data sets. If you directly connect to 480 billion rows of data using a tool like Tableau, it's likely you're not going to get the interactive response time that you expect if you're a Tableau user. Governance and data security remain a really big issue. While there is a desire to allow more and more people to access data that's sitting on a Hadoop cluster, enterprises are really thinking about how do I provide a governed way and a secure way of providing access to the right data for the right self-service users. And the other thing that we see is people are really jumping through a lot of hoops to do this. They're moving data off the cluster, they're creating extracts, they're really kind of, I would say, struggling from a technology stack perspective, trying to bring those BI tools directly to Hadoop data. And this is really where AtScale comes in. The problem that we set out to solve when we founded AtScale is this picture right here. On the left-hand side, you've implemented your Hadoop cluster or you're implementing your Hadoop data lake. And from an IT perspective, you're trying to present the data in a consistent way, in a controlled fashion. On the other side, you've got a bunch of self-service business users using Tableau or Qlik or MicroStrategy or Excel, and they're trying to connect to that data. And in between, they struggle. What AtScale does is it provides a virtual interface that exposes a dimensional model or a traditional OLAP-style model to data that's sitting on the Hadoop cluster. We support the two top query languages that these BI tools talk, which is either SQL or MDX. And the other thing that we do is we provide some optimizations. We manage something that we call our adaptive cache. The adaptive cache is a series of aggregate tables that exist on your Hadoop cluster, but they deliver optimal performance. We aggregate and summarize often queried data sets, and we make it so that as a Tableau user, you're querying those 480 billion rows of data, but you're getting a response time that is interactive. From an architectural perspective, what this means is that you can connect your BI tools of choice using the data drivers of choice, whether that's SQL over ODBC or JDBC, or MDX over an XMLA connection. Those tools talk to the AtScale engine, and the AtScale engine does two things. The first thing it does is it pushes queries down to your Hadoop cluster, And we leverage the SQL-on-Hadoop engines. Today we'll talk about Impala, Spark SQL, Hive, and Presto. We leverage those engines to do all of our heavy lifting. The other thing that we do is we manage our adaptive cache, or our set of aggregate tables. Those aggregate tables exist on the Hadoop cluster. They're written as Parquet tables or org files. And we will be smart about querying those aggregate tables if they exist, instead of going back to the raw data. In this case, we also use those same SQL-on-Hadoop engines to query the aggregates. In this context, I'm providing it because it will give you a good sense of the framework we've put in place for our benchmarks. You'll see that we look both at engine performance against raw data, as well as the aggregate tables that comprise the AtScale adaptive cache.
Thanks, Josh. I'm going to jump back in here, everyone, really quickly, because one of the points that Josh made there had to do with the fact that we work with most of your favorite BI tools. And so I'm going to start a poll just to get a sense of what BI tools are you using. And based on the system here in BrightTalk, you can only choose one. So I would ask, what BI tool do you use primarily in your organization? This would be, once again, of interest. You can kind of see what those others in the audience are utilizing. The ones we see most often, Excel is always around, right? #1 BI tool globally. But many organizations often have a mixture. They may use a lot of the newer visualization tools, such as Tableau or Qlik, but many of the organizations we've run into have also utilized some of the more traditional MicroStrategy or business objects. Interestingly enough, those in our audience today, Josh, it looks like a majority are around the old school or Excel, and okay, now we're getting more of a mixture, but still some of that Excel ubiquitous, so that's consistent with our experience, and as well as some homegrown systems, which we are often seeing. Sometimes you need something internally that just to do exactly what you'd like. And so with that, we appreciate your taking that poll. It looks like the winner at this point, primarily in use, is a lot of those newer visualization tools, with Excel coming in close second. So at this point, we're going to stop. We're going to close the poll and jump back in and let Josh and Trystan share more of the details around the benchmark. Thanks, everyone.
Thanks, Irina. And this is, I like looking at these polls, and this confirms, one of the core premises of AtScale is there's not just one winning BI tool. Excel is everywhere. We see large adoption of self-serve BI tools like Tableau and Qlik, as well as enterprise standards, whether it's a MicroStrategy or business objects or a homegrown system. What we're doing with AtScale is we're providing an interface that can support a shared semantic layer across all of these tools. And as I said, architecturally, we subsequently take those queries, whether they're MDX queries or they're SQL queries, and we push them down to the Hadoop cluster, and at that point we execute them using the SQL-on-Hadoop engines. And that really takes us into the framework for our benchmark. When we looked at the benchmark, we looked at 3 different evaluation criteria for each of the SQL-on-Hadoop engines. And these are the terms that we use internally, but the first thing we look at is, does it perform on big? So we want to understand, when we execute a raw SQL-on-Hadoop query with one of these engines, and we're looking at billions or even trillions of rows of data on some of the larger clusters, do we get response times that are acceptable? And I wouldn't say they're interactive. We're not getting response times in a few seconds, but we may be getting response times in a minute or two. What we really want to ensure is that these engines can complete those queries without failure and without error, and satisfy the original query. The other thing that we look at for these engines is we want to assess whether they're fast on small data. And small data, in this case, might be tables that range from hundreds of thousands to even a billion rows of data on your Hadoop cluster. Depending on the size of the cluster, that could be small data. But what we want to ensure is that these query engines are delivering the interactive performance that a Tableau or Excel user expects. If you're used to using pivot tables and SQL Server analysis services, or if you're used to using Tableau with Tableau data extracts, you're expecting queries to come back in a few seconds. And so it's really important that the SQL-on-Hadoop engines can return queries against the adaptive cache in an acceptable period of time. The third thing we look at is concurrency. If you think back to that picture I showed of the BI users on the right-hand side, we are really trying to support BI workloads. We're not looking at specific data engineering or a small number of data science users. We're not looking at data wranglers or data engineers. What we really want to ensure is that if you have an enterprise user base that's on the order of hundreds or thousands of users, and you're querying at scale, what does performance look like? As the number of concurrent queries grows, how do these engines degrade, or what does their performance look like, and can they remain stable and satisfy those queries? So that's really, you'll see this context when we present the results, that we're going to look at these three aspects of performance for all of the engines that we looked at. So I'm going to hand things over now to Trystan, and Trystan is going to provide a little bit more context around the environment that we used to actually do the benchmark tests.
Thanks, Josh. So, you know, our Hadoop cluster isn't as big as yours or as big as a lot of your people from before. You know, we just had a very small Hadoop cluster in this case, 10 nodes we went with. It's what fits in our racks, and it gets us a good sized Hadoop cluster versus the data we were seeing. So this is a 10 node cluster. We had one master and one what we call a gateway node that AtScale ran on. And it's a pretty standard node you would see, 128 gigs of RAM, 32 CPUs, and SSDs. That's probably the least standard, but we wanted to see what we could get out of the performance out of all of this. And the Hadoop, we set up a standard Hadoop 2.6 on it. It was the same for every engine we ran. We ran bog standard Hadoop. We ran each section 10 times, which would be average of the queries for each of the engines, and we ran them all in the same way to get the best, most accurate results we possibly could. And so we picked the three engines, and at the time these were the three newest engines, or the three newest versions of these engines. We picked Spark 2.0, that should be. But we picked 2.0, we picked Impala 2.6, we picked Hive 2.0, 2.1 actually, with TES version 0.8 and LLAP, and Presto 0.152. These were the newest at the time. Actually, for both Spark and Hive, we did make some alterations just to get the even newer versions to fix some bugs we were seeing. But most of these are very easily picked up on any of the new Hadoop platforms, and they're very standard. And that's what our goal was with this. Was we pick standard SQL engines, we pick configs that you on your clusters could make. That was our goal with this one.
Yeah, and Tristan and I were just looking at this slide, and we realized that the versions we have there for Spark and Impala and TES or Hive are from the first edition of the benchmarks. We did look at Spark 2.0, Impala 2.6, and Hive 2.1 with LLAP for this particular set of benchmarks.
And so the data set we use is a star schema benchmark, which is a version of TPCH. It just has less tables. They combine the tables. And this is a more, what we would say, a BI table data set rather than analytical, which is the TPCH. And we messed around, and our goal was to have a very big query, big table to big table join. That's something we really wanted to test because it's something that does happen quite a lot. And that's why we came up with these numbers. We had, a 6 billion row table, a 1 billion row table, and some other dim tables in there. So we could get a very big join going, the 6 billion to the 1 billion, plus, smaller dims to see how all that performs and how that went along.
Yeah, and one comment there. The default, when we scaled this data set up to these 6 billion rows for the line order, which is really the fact table here, by default, the customer dimension is 1 million rows. But for our test and what we see in the big data use cases that we're trying to support is big joins tend to be a real challenge for the SQL-on-Hadoop engines. And this is a theme that you'll see across our benchmarking, is our objective here is not necessarily to make these engines go as fast as possible. What we really want to do is put them through their paces. And one of the ways that we did that, if you look at the queries that we used for the benchmarks, is we ensured that the more complex queries in our test suite included a join with that 1 billion row customer table. And this is something that I think attendees on the phone should be mindful of and think about as you start to move on your BI-on-Hadoop journey, is making sure that you've got an architecture and an approach that can handle what we call these high cardinality use cases in these high cardinality joins. Because what you will see if you're looking at sensor data, if you're looking at web traffic data, if you're looking at supply chain data with huge product catalogs, you're going to see very large dimension tables. So the 13 queries that we ran through our test suite were really increasing in complexity. The first set, Q1 through the query 1 set of queries, are really looking at a metric for a time period, maybe for a particular region or for a particular product, with an increasing number of filters. We increased the size of the join for queries 2.1 through 2.3, and then in queries Q3 and Q4, we really added that 1 billion row join. And you can see that with the increasing number as the queries go up, we've increased the size of the join. We've increased the number of group bys. We also increased the selectivity. So, for example, query 4.1 to 4.2 to 4.3 is increasing in terms of the selectivity, the amount of data that's getting filtered. So query 4.3 is fundamentally looking at less data than query 4.1. And having this setup for the queries allowed us to look at a few different things: performance for large joins, performance as the number of group bys increases, and performance as the number of filters increase on the data set. Another thing that we included for our benchmark is a real bearded wizard. That's Trystan. And I say this only half joking, that it is helpful to have a bearded wizard when you're working with performance and scalability testing on Hadoop. It is still an early technology. We've seen huge improvements over the past few years, but it does take some expertise to ensure that you're properly tuning the SQL-on-Hadoop engines, that you're formatting your data properly, that you're kind of turning levers the right way to get performance out of the Hadoop cluster. At the end of the session, Trystan will provide some of the tips and tricks that he's learned across those engines. But it really, you need to make sure that you've got the right investment, not just in your Hadoop infrastructure and hardware, but also in the people that you're putting around your Hadoop cluster.
Great. Thanks so much, Josh. So we've taken you through sort of the setup. Josh has really given you and Trystan a sense of what the environment was. At this point, I'd like to jump really quick into one more poll, and this one has to do with what platform you're using. So we were talking about some of the different engines, but we also know that many of you use different platforms. You're using either big data or Hadoop. And so we're interested in what our audience out there. For those of you who said that you are already implemented, some of you have a small number of nodes, some large. Are you using some of the standard distribution? It looks like Cloudera and Hortonworks. For those of you who said you weren't implemented yet, it makes sense that you're answering the last. And then there's MapR. Obviously, there's a lot of big data situation engines out there, a lot of big data platforms, rather. And so we can only include so many of this. But this will give us a sense, and it looks like we've got about 20 more seconds, so if you'd like to participate, we definitely encourage you to. But it looks like there's a pretty neck-and-neck running between Cloudera and Hortonworks right now, based on our audience today, and then a number of you who aren't quite sure or just haven't jumped in. Looks like some of you out there are on MapR, so thank you very much for contributing. Definitely, we're partners with MapR, and it looks like Amazon has also participated, so great. Many of you out there are across a number of different items, so we appreciate your participation, and let's go ahead and jump back into the rest of today's presentation. Josh, we see the good spectrum of variety of platforms being used, and now our users are probably interested in hearing the results of our benchmarks so that they can put them into practice in their environment.
All right, so let's dive into the good stuff. Great poll results. Just like we saw with the BI tools, the other thing that we see is a variety in both the Hadoop platforms that are being used, as well as the SQL-on-Hadoop engines that are being used. So let's dive right in and look at the results. If you remember, there were really three things we looked at for the engines. Are they fast on big? Are they fast on small? And concurrency. So the results you're seeing on this slide are the results for Impala, Spark, Hive, and Presto on our large data set. So that 6 billion row data set across queries Q11 through query 4.3. And a few things that I'll note here. The first is for the query Q1 and Q2 style queries. These were on aggregate tables that were relatively small, on the order of hundreds of thousands up to millions of rows of data. And what you see is Impala and Spark look pretty close together. Hive and Presto are a little bit slower, but all these engines are relatively within the same range. With queries 3 and queries 4, we introduced that 1 billion row join. And you can see that we started to see a larger difference between Impala and Spark kind of track together, and then Hive and Presto start tracking together with a big difference between those two query engines as we add in that 1 billion row join. Trystan, I don't know if you have any particular commentary on what happens as we start to do the larger joins and why we're seeing that good performance out of Impala and Spark.
So fundamentally, both Impala and Spark do the same thing to get the much faster queries, especially for 4.2 and 4.3, which, as Josh said, they become more filtered as we go up. And that's where Impala and Spark and their runtime filtering. So what they'll do is they'll do the joins on all the smaller tables, and by the time it gets to joining to the big fact table or even reading in the fact table data, it knows what keys it should read in. So what it's doing is they're smartly filtering what it needs to read in and what it needs to process long before it has to process it. Right now, both Presto and Hive don't have that feature, which is why they're very roughly the same in terms of speed and for 4.2, 4.1, 4.3, and they're kind of standard across the thing because they do read in all 6 billion rows and do join all 1 billion rows, while Impala and Spark both don't. But this is something that I think both engines are looking into, Hive and Presto, and something that does help dramatically with the speed in those situations. Yep,
great stuff. And then the other thing that we see here is that starting with queries, the 4.1, 4.2, and 4.3, we start to see, while Impala and Spark are roughly equivalent, with Impala sometimes being faster than Spark up until queries 4, with queries 4.1, 4.2, and 4.3, Spark starts to slightly outperform Impala. I believe this is due to the way that, what does it do to?
So it's due to the join and the way that they've implemented it, pretty much. It's coming down to how the join is done underneath. They're both joining on very large data sets, and they're both doing a broadcast join in this case, so that's actually not true. They're both, at the very, very large set, they're doing a shuffle join. So it's slightly different implementations, and Spark just seems to be slightly faster in this case.
So this is, one of the key takeaways here is, if you look at these charts, while you see certain engines tracking together, two high-level observations. The first is all of these engines were able to handle that 6 billion row data set. There are definitely differences from a performance perspective from one engine to another, but there's also, there's not a single winner. Depending on the size of the data and the size of the join, you'll see performance differences across these engines where one looks better than another. And kind of keep that in mind as we're going through this presentation. Now, the next view is looking at small data sets. So these are semantically the exact same queries, queries 1.1 through query 4.3, but this time instead of the AtScale engine routing these queries to the raw data and rolling up the 6 billion rows, we were able to route those queries to aggregate tables that had enough information in them to satisfy the parameters, the aggregations, as well as the filters and group bys that are in these queries. I mean, what you'll see here is across the board, we're seeing really nice response time. So instead of, if we go back to the large query screen, where we were seeing query times on the order of up to 140 seconds for some of the large queries, when we go to the small queries and we're hitting aggregate tables, almost all of the queries complete in 5 seconds or less. And so you can imagine yourself as one of those Tableau users or Excel users or Click users. This is a much nicer experience. You can interact with the data, you can ask questions of the data, and you can do this consistently across all of the different query patterns that we're seeing. You'll see that for those smallest queries, so query 1.1 through 1.3, Presto, Impala, and Spark SQL tend to outperform Hive, but moving up in terms of complexity, Hive starts to look a lot closer to the other engines. And we'll show the performance improvements we saw from version to version in a moment. But one of the things that I'll comment on here is with the launch of Hive with LLAP, Live Long and Process, we saw much better performance from Hive on the small tables versus the previous evaluation we did around 6 months ago. The final thing that we looked at in our framework is concurrency. And I'm going to present two concurrency results here. The first is what we called in the benchmark, which I think participants will receive a full copy of the benchmark as a follow-up to this webinar. We call these quick metrics. These are really dashboard metrics, looking at a few metrics over a few products over a period of time. And what we did is we ran those dashboard metrics, and these are in our benchmark, these are queries 1.1 through query 2.3. We ran these queries with 1 user, 5 users, 10 users, 25 users. And these are truly concurrent queries, meaning we submitted 25 simultaneous queries. And what we wanted to look at is how do these engines perform from a response time perspective as you submit these queries. And for these queries, we saw a pretty significant difference with Impala and Presto due to their kind of traditional MPP style architecture. They handle these quick insight concurrent queries really, really nicely with not much degradation. With Hive and Spark, we did see that as the volume of queries against these engines increased, we saw kind of a linear degradation in performance. Now, none of the queries failed, but they do slow down more significantly than Presto and Impala for these quick metric queries. The other thing that we looked at are what we would call the analytic queries. These are the more complex 3.1 through 4.3 queries with the larger joins and more group bys. And again, I wouldn't, and you shouldn't expect these queries to all come back in a few seconds when you've got 25 simultaneous submissions. But what you do want to see again is a linear degradation of performance. You want to be able to appropriately say, I know the query is going to come back and it's going to return, and as query volume increases, I'm going to see a kind of a linear increase in query response time. The reason this is good to see is it means that, as Tristan mentioned, we are on a 10-node cluster. It means that if you scale to 20 nodes or 30 nodes or 50 nodes, the way that you can improve the concurrency profile is to add more resources to your cluster. There isn't a bottleneck here that's preventing these queries from completing. It really is the amount of resources you're allocating from a throughput perspective. Tristan, I don't know if you have anything additional to add or if I've just summarized everything perfectly.
It's a great summary.
All right. Thank you. The other thing that I mentioned is we did compare the performance for the first edition of the benchmarks. We did not include Presto, so you won't see the version-to-version comparison here. But when we went, for this version of the benchmarks, we went from Hive, I think it was Hive 1.2 to Hive 2.1. We went from Spark 1.6 to Spark 2.0, and from Impala 2.3 to Impala 2.6. These were the releases that came out essentially in a 6-month period between March and today when we executed the benchmarks. And what you'll see here, I think, is super promising. The empty bars here represent the previous performance on aggregate, and the full bars represent the aggregate performance this time around. And what you'll see is for big queries, we saw great improvement across the board. Spark, 2.4 times faster on average. Impala, 2.8 times faster on average. Hive was 3.4 times faster on average. When it came to concurrency, Spark and Impala remained good on concurrency. Hive was 2 times faster from a concurrency perspective, on a small query perspective. We also saw really nice performance gains in terms of concurrency, with both Spark and Hive showing significant gains, really catching up with Impala. Impala has consistently been the leader when it comes to concurrent query support. What this means to us architecturally at AtScale, and I think one of the things that is relevant to this audience, there is huge performance gains that are happening in the SQL-on-Hadoop ecosystem. And so the AtScale architecture, which is really depending on the underlying data platforms to provide the scale and performance through the delivery of these SQL-on-Hadoop engines, what this means is, AtScale, by simply doing nothing other than leveraging these SQL-on-Hadoop engines, we've gotten between 2.4 and 3.4 times faster simply over the past 6 months through the improvements that we're seeing on these SQL-on-Hadoop engines. It means that you can really rely on these SQL-on-Hadoop engines to continue to improve over time. Again, you'll pick the right one for your use case, but what we're seeing in general is these SQL-on-Hadoop engines are great candidates for doing real-life workloads. And I'll share some examples here. This is a few results from live implementations of AtScale. One of the customers that we worked with, a large automotive company, relatively small cluster, looking at 2 billion rows of data, and what they were comparing us with was a current process where they were extracting data from their Hadoop cluster. They were building Tableau data extracts that tended to be really large and unmanageable, 60-plus hours to process that Tableau data extract, and then because it was so big, performance was not great for those Tableau users. With AtScale and Impala as a query engine, we were able to deliver query performance in under 10 seconds for virtually every query against the cluster versus the 120 seconds, and to create that AtScale adaptive cache and the aggregate tables took under 2 hours instead of 60-plus hours. And we thought this was a really nice proof point of the AtScale plus SQL-on-Hadoop engine plus Hadoop platform architecture supporting those self-service BI use cases and doing it in a way that delivers improved performance. Another customer of ours was comparing us to a stack where they had AtScale, or they had a Hadoop cluster, they had Tableau, and in order to get performance, they had an MPP database in between. They were bulk loading. They were using that Hadoop cluster for batch processing. They were taking the results of that batch process data. They were bulk loading it over to an MPP database. They were using Tableau on top of that database. But they wanted to eliminate that step in between. They really wanted to use their Hadoop cluster not just for ETL, but to support those BI workloads. And through the combination of Hive and Spark SQL as our SQL-on-Hadoop engines and the creation of that adaptive cache, with AtScale, we saw some really nice performance gains versus that traditional MPP database. And again, this is, for us, another proof point that Hadoop clusters plus the SQL-on-Hadoop engines that are sitting on those Hadoop clusters are really ready for prime-time BI workloads. Things that traditionally are handled versus using extracts or MPP databases can now be handled using those SQL-on-Hadoop engines. So, as I mentioned, one of the things that we have found working with these SQL-on-Hadoop engines is it does require a little bit of tuning to make sure that you've got them tuned properly for optimal performance on your use case. And I think there are probably more than 3 tips and tricks for each of these engines, but I've asked Trystan to just share some of his thoughts on kind of what he had to look at in order to get the best performance out of the 4 engines that we looked at.
Thanks, Josh. So the one big thing you'll see across all 4 engines is the file format. File format plays a really important part into, you know, the speed you can get and how the SQL engines perform. They all have their preferred file format. In the case of Spark and Impala, it's Parquet. They spend a lot of their time optimizing Parquet. They optimize the reading it in. They optimize how they store it, everything like that. So for those 2, you should really be running in Parquet format. And for Hive and Presto, they both use the ORC file format. With Presto, they've written their own reader to make it even faster. With Hive, they've written a lot of their code and to make reading in ORC a lot faster. So they're the 2. That's probably the biggest thing you can do with tuning your SQL engine, is picking the right file format. And there are other options. You can, you know, gzip it or lzip it or snap decompression in there. And depending on your workload, everything like that, that's where you're going to go into. As for other tips and tricks, it comes down to a lot how you either do the joins, either for Spark, tuning the broadcast join threshold. So broadcast joins are significantly faster across all of them. They all have, each engine has its own broadcast join, and each engine has its own way of hitting the broadcast join. And so hitting that broadcast join is the way you should get a lot of performance out of those big joins. In terms of Spark, you hit, you set a threshold, and if it goes above that, it changes the join automatically. But for Impala, it doesn't have that quite yet. So using the join hints to tell it when it should do certain types of join in situations. So for example, if you're joining the 6 billion to the row table to the 1 billion row table, using a shuffle join is superior than broadcast join. So in that case, using those join hints in Impala is great. Hive has a similar feature, and Presto right now it doesn't have anything like that, but they're looking into it as far as I can tell. So, joining is a big thing. Join ordering for Presto is a big thing. So you should, order your joins. Depending, it's usually the largest table on the left and then the smallest to largest on the right. But you're going to have to experiment that, and it comes down to your workload. But joins seems to be the biggest thing here. There's a couple of other things specific to each engine. In this case, Spark, the shuffle partitions, you can tune that up or down to get more workload. Depending on how big it is, you want smaller shuffle partitions if you're running across small data sets, larger if you're running across larger data sets, and it just you have to watch that and tune for that specific query. In AtScale, we do all that automatically, but if you're running it manually, you're going to have to go and do that. Impala, the runtime filter, which got those great results with the 6 billion row tables, is very important, and that's an Impala 2.6 above. Setting that up to be global so it will always filter, and watching that is a great way to gain some performance. For Hive, enable vectorization is where you're getting your speed from the ORC files, and of course now LLAP is where the speed really comes in. So getting LLAP, enabling that, getting it to cache the I/O and everything, that's where you're going to get your great speed from in Hive nowadays. So getting up and running with LLAP is a good idea. For Presto, you've got to tune the threads and the concurrency depending on your cluster size, depending on the cores and everything, and they have some great documentation around that. And then there's another thing of the buffer size, of how much data gets shipped around and how big that buffer subset can be. So there's a lot more than that, but they're the big ones that you can gain quite a bit of performance just by doing these.
Great, thanks, Trystan. And as you can tell, for each of these engines, there is some tuning and best practices that really help you get the best out of each of them. And although we love sharing benchmarks with the folks that are in the audience today, one of the other reasons that we do these benchmarks is it helps us from a product development perspective. The more that we learn about the decisions that lead to optimal query performance for these different engines, we actually modify our core engine code so that when we submit a query to Spark or Impala or Hive or Presto, we're submitting an optimal query based on what we've learned from a performance perspective. So let's wrap things up. I think we are almost exactly on time because I was supposed to talk with Trystan for 45 minutes, and I think we're good there. That will leave us a little time to answer questions. But just in summary, here's at least our assessment based on the results that we had in the second edition. The first is we really think, one, the SQL-on-Hadoop wars are continuing, and we think that's great because everyone wins. The performance gains that we're seeing across the board for all of the engines are fantastic. I recently saw some benchmarks published by Cloudera. I think that what they've seen in the past year is depending on the query size, a 4x or more improvement in Impala queries, and we're seeing that. Same thing we've seen with Hive and LLAP is really just vastly improved performance from version to version. We think that's great for you, for the user of the Hadoop cluster. What that means is the investment in the ecosystem is still there, and it's yielding great dividends. There is no single winner. We saw, Presto really was great when it came to concurrency, in fact, beating out all of the other engines. We see Spark doing a great job of handling complex joins. We see consistent performance across the board with Impala. We've seen great improvements in Hive, and Hive with LLAP is now a viable option for both those large and small queries. We've seen with Presto and Impala, I think the concurrency looked really good. And I think the summary for us really is if you're pursuing a BI-on-Hadoop architecture, really think through and understand your query workloads. And it may mean that you need more than one engine. That's one of the things that AtScale has been designed from the beginning to support is the use of different engines for different query patterns. If anybody out there is an AtScale customer or has worked with us from a demo or a POC perspective, you may recall that when you create a connection to your Hadoop cluster, you can select up to 3 different query engines to execute different query types, the small queries, the big queries, the batch creation queries. So hopefully this has been helpful. There will be some resources that you receive follow-up. I think there are also links that are attached here for you to use. How about, Irina, should we do Q&A, or were there any other calls to action you wanted to talk about?
Let's wrap up with a quick call to action. It won't take very long. And then we do, in fact, have a number of questions that have been submitted by our audience, so I wanted to thank you. For those of you who may need to leave early, and those of you who were intrigued by not only the benchmark results, but some of the key findings that Josh shared, specifically those of you who are looking to put BI workloads on Hadoop and would like to consider being able to automate or use those multiple engines and learn more about how AtScale does that. So I encourage you we've got a number of links here. These are also shared down in the attachments and links, so reach out to us. We'd love to hear from you. But for those of you who did submit questions, let me go ahead and we'll address those with Josh and Trystan right now. So one of the first questions that was submitted is, do you have plans to include Drill and Hawk in the benchmark?
So the answer to that is yes. We are always adding additional SQL engines to our benchmark, and really our kind of the decisions that we make in terms of which engines to include are really based on what we see in the marketplace. In fact, I was just speaking with a customer this morning or a prospect this morning about Hawk. We are working with a lot of MapR customers, and so we're seeing increased interest in Drill. So yes, in future editions of the benchmark, we will continue to add more SQL-on-Hadoop engines, and Drill and Hawk would be the next logical choices.
Perfect. Great. Thanks for that. Another question that came in says, regarding the reduction on ETL, I think this is referring to the earlier maturity results. Regarding the reduction in ETL, when comparing to BI usage on Hadoop, do you think that some adopters are considering other options for ETL, or are the BI needs exponentially increasing?
Yeah, so I think this is maybe opinion versus statistical fact. I don't think people are moving off of Hadoop to do ETL. I think it really is that the BI needs are increasing. And the kind of the logical path I think that Hadoop adopters are going through is their initial investment in Hadoop was to support ETL offload, and what they're discovering is all of a sudden they have some really nicely structured large files sitting on their Hadoop cluster, and they're scratching their heads and saying, okay, well, why am I now moving this data back off of the Hadoop cluster? I've got a parallel processing infrastructure, it's low-cost storage. Can I start to bring more workloads to this data set instead of moving it off the cluster?
Great. Thanks again for that answer. Some other questions that were submitted. One here is, I think, asking for a little bit of clarification based on some of our findings. It says, with AtScale, I do not need to choose the engine, that being a question.
Yes. Well, there's two levels of choice. The first is the engine, the SQL-on-Hadoop engine needs to be available on the cluster, and that either meaning it's been pre-installed. For example, Impala has been pre-installed, or Hive LLAP has been pre-installed. AtScale also ships and manages its own version of Spark, which we deploy and manage versus Yarn. What we're really saying is that as a BI query user, when you submit a query to AtScale, we will use the best configured engine for the job. So if you've configured AtScale to use Hive and Spark as potential options for data processing engines, the AtScale query optimizer will figure out the best engine to use to satisfy that particular query.
Perfect. Another question here. Are there any results for analytical workloads?
So we did not focus on analytical workloads. If you've looked at other benchmarks like TPC-DS, which is really oriented around more data science and analytic workloads, there are other publicly available benchmarks for those workloads. We really, because our use case and kind of the AtScale focus are BI, traditional BI workloads, the kinds of workloads that get generated by a BI tool, those are the ones that we focused on.
Okay. Next up, were the MPP versus AtScale plus SQL engine on Hadoop comparisons running on similar MPP configured hardware? I think those were from the examples of customers near the end.
You know, that's a good question. It's tough to do an apples-to-apples comparison. The Hadoop environment for that MPP comparison is a multi-tenant environment where we were provided a portion of the resources on that cluster. The cluster itself is probably a lot larger than the MPP system. The resources allocated to us, I'd say, were roughly equivalent. From a total cost perspective, the cost of the Hadoop resources plus AtScale were significantly less than the cost of the MPP system. But I think that's a fair question because it comes down to kind of the cost of performance, and at least in that customer's experience, the Hadoop plus AtScale solution was a much lower cost solution for better performance.
Great. A couple other questions it looks like our audience has submitted. One has to do with those multiple engines, but it's a slightly different perspective, Josh, so you can clarify if you think that this just is a repetition or not. It says, can you elaborate on the possible need to have multiple engines?
Yeah, so I'll give you kind of a simple example for this. One of the things that we've seen for very large data sets where you've got joins that potentially might go beyond the memory bounds of your processing engine is that Hive can be the most stable option. But once those aggregate tables have been created and the AtScale adaptive cache is available, Hive might not be the best engine to support either a large number of concurrent users or very fast queries on small data sets. Even with LLAP, we are seeing response times on the order of 1 or 2 seconds, while Impala and Presto and Spark SQL can return in sub-second response time. So that might be if a typical configuration is Hive for stable processing of really big data sets. Where really big is 400, 500 billion rows or a trillion rows.
Okay. Are there any plans for testing IBM Big SQL?
Not currently. We have been focusing more on the open source engines. One of the next ones I see here, I like this question, and I'd like to touch on it, is the question about concurrency, and that the results that we saw were very linear. And that's a good observation, and I touched on it really briefly. This is essentially because the queries that were being pushed through, let's say, Spark and Hive, where we could see that linear behavior the most clearly, it's really a throughput-based system. How much, what is the capacity to handle a series of queries, and the constraint is throughput. And so as we submitted more and more queries, those queries queued up but could be consistently satisfied by the available throughput of those query engines. What this indicates to us is that as if you were to say double the size of the cluster that you're doing the testing, you're basically going to cut the concurrent query performance in half. So if you double the resources, you double the throughput of the system, you're going to see linear improvements in scalability. So this is what I think is going on there. We haven't tested that beyond our 10-node cluster, but it's one of the things that we will focus on in a future benchmark.
Great. All right. Well, just a couple more questions, and then we'll be wrapping up. It looks like we've got about 3 minutes left till the top of the hour. One of the questions has to do around BI and BI on big data, and it is the star schema still relevant for big data BI?
Maybe. Good question. What we see, with AtScale, we're providing an abstraction layer that looks like a dimensional model on top of underlying data sets. For our implementations, the data that we're looking at has ranged from a star schema, and typically the star schema is the result of someone taking an existing schema off of an analytical data warehouse or off of an EDW and shoving it into Hadoop. So it's already in a star schema. But we have other customers where we are working with big, fat, wide log tables, 3,000 columns of data with completely denormalized, with no dimension tables. Sometimes we're working with an OLTP schema that's just been shoved over into Hadoop. So I'd say the star schema it is relevant because sometimes we are working with data that's in a star schema, but it is not required.
Great. Okay, with just a minute, we do have a couple of other questions submitted in here. For those we were unable to get to, we will email you those answers. Once again, I want to thank our audience for the great questions, the great interaction. Thank Josh and Trystan for their deep dive into the benchmark. And just a quick reminder for those of you, we will be sending everyone in attendance a copy of the benchmark, so you will be getting those. And if you have additional interest in understanding more how AtScale helps to further improve BI on Hadoop, we encourage you to grab any of the attachments or links here in the Bright Talk presentation, or go to any of these URLs that you see on the screen. So with that, I'll thank everybody once again and wish you a good day.